When designing a tenant improvement within a mall, determining the available fault current to the point where the tenant receives electrical service is crucial for ensuring the safety and reliability of the electrical system. If you cannot obtain the available fault current, follow a systematic approach to develop the fault study for the tenant panels. Firstly, request information from the mall management. Reach out to the mall management or the property manager to obtain the available fault current at the point of connection. Explain the necessity of this information for the design of the tenant improvement electrical system. The mall management should have records of the utility feed and any upstream overcurrent protection devices, which are essential for calculating the available fault current. Secondly, if information cannot be obtained from mall management, estimate the available fault current conservatively based on industry standards and reasonable assumptions. For example, assume a typical maximum available fault current in a mall of 25,000 amps. Reduce the available fault current by a safety factor, such as a factor of 2, to account for possible future increases in electrical load or changes in the utility supply. This results in an estimated available fault current of 12,500 amps. This conservative estimate will help ensure that the equipment selected has an adequate interrupting rating. Thirdly, inform the electrical contractor of the estimated available fault current or the need to verify the actual available fault current. Discuss the importance of verifying the available fault current during installation to ensure the adequacy of the tenant electrical system. The contractor should perform an on-site fault current calculation or measurement to confirm the available fault current at the tenant's service entrance. Fourthly, document the estimated available fault current or the requirement for verification in the design documents. State that the electrical contractor is responsible for verifying the available fault current and updating the design accordingly. This documentation is crucial for liability and future reference. It is not acceptable to leave it solely up to the contractor to verify the fault current. The design professional has a responsibility to provide accurate and complete design documents. Leaving it entirely to the contractor may result in an inadequate design or the selection of equipment with insufficient interrupting ratings, potentially leading to hazardous conditions. Assuming a large available fault current may result in an over-design of tenant electrical equipment, including switchboards, panel boards, breakers, and wiring. This can lead to increased costs and potential space constraints. Over-designing can also lead to inefficiencies and unnecessary complexity in the electrical system. The recommended approach is to exhaust all efforts to obtain the actual available fault current from mall management. If this is not possible, estimate the available fault current conservatively and note the requirement for verification in the design documents. Discuss the importance of available fault current verification with the electrical contractor and include it as their responsibility. The design professional should provide a clear scope of work for the contractor, outlining the steps for verifying the available fault current and updating the design as needed. When estimating the available fault current, consider several factors. Firstly, the size and impedance of the utility transformer supplying the mall. Larger transformers typically have lower impedance, resulting in higher available fault currents. Secondly, the length and size of the conductors from the transformer to the tenant service entrance. Longer conductors have higher impedance, which reduces the available fault current. Thirdly, any upstream overcurrent protection devices, such as fuses or circuit breakers, which can limit the available fault current. Consult with the local utility company to obtain information about the transformer size, impedance, and conductor characteristics. This information will help refine the available fault current estimate. The electrical contractor should use appropriate equipment and methods to verify the available fault current. Firstly, they can use a fault current meter to measure the actual available fault current at the tenant's service entrance. Secondly, they can perform a calculation based on the transformer impedance, conductor characteristics, and upstream overcurrent protection devices. Thirdly, they can consult with a qualified electrical engineer to perform a detailed fault current study. The fault current study should consider all potential fault locations within the tenant's electrical system. This includes bolted faults, arcing faults, and line-to-ground faults. The study should also consider the impact of motor contributions and other sources of fault current. The results of the fault current study should be used to select appropriately rated overcurrent protection devices such as circuit breakers and fuses. These devices must have an interrupting rating equal to or greater than the available fault current at their location. The design professional should review the contractor's available fault current verification and ensure that it is accurate and complete. The design professional should also update the design documents to reflect the verified available fault current. The design document should include a single line diagram, panel schedules, and a fault current study report. The single line diagram should show the electrical system from the utility service entrance to the tenant's distribution equipment. The panel schedule should list the overcurrent protection devices, conductor sizes, and equipment ratings for each panel board. The fault current study report should document the available fault current calculations and the basis for selecting overcurrent protection devices. The electrical system design should comply with all applicable codes and standards, including the National Electrical Code, or NEC, and local electrical codes. The NEC provides specific requirements for overcurrent protection, conductor sizing, and equipment ratings based on the available fault current. The design professional should be familiar with these requirements and ensure that the electrical system design meets all applicable codes and standards. Regularly communicate with all stakeholders, including the mall management, electrical contractor, and local utility company. This will help ensure that all parties are aware of the available fault current requirements and that the electrical system design is coordinated and safe. Document all communication and decisions related to the available fault current verification and electrical system design. This documentation will be valuable for future reference and for resolving any disputes that may arise. In addition to the available fault current, also consider the voltage drop in the electrical system. Excessive voltage drop can cause equipment malfunction and reduce performance. The electrical system design should minimize voltage drop by using appropriately sized conductors and minimizing the length of the conductors. Perform voltage drop calculations to ensure that the voltage at the equipment terminals is within acceptable limits. The NEC provides guidelines for voltage drop in branch circuits and feeders. Consider the impact of harmonic currents on the electrical system. Harmonic currents can cause overheating of equipment and increase losses. The electrical system design should mitigate the effects of harmonic currents by using harmonic filters or other appropriate measures. Conduct a harmonic analysis to determine the level of harmonic currents in the electrical system. Also consider the grounding of the electrical system. Proper grounding is essential for safety and for minimizing the risk of electrical shock. The electrical system should be grounded in accordance with the NEC requirements. Verify the grounding system during installation to ensure that it is properly installed and functioning correctly. Include a surge protection device to protect the electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. The surge protection device should be sized and installed in accordance with the manufacturer's instructions. Perform regular maintenance on the electrical system to ensure that it is operating safely and efficiently. Maintenance should include inspecting and testing overcurrent protection devices, conductors, and equipment. Keep records of all maintenance activities and repairs. Train the tenant's employees on the safe operation of the electrical system. Training should include instructions on how to identify and respond to electrical hazards. Provide the tenant with a copy of the electrical system design documents and maintenance records. Consider the future expansion of the tenant's electrical system. The electrical system should be designed to accommodate future growth and changes in electrical load. Provide spare capacity in the panel boards and raceways to allow for future additions. When selecting equipment, consider the energy efficiency of the equipment. Energy-efficient equipment can save the tenant money on their utility bills. Select equipment that meets or exceeds the minimum energy efficiency standards. Use lighting controls to reduce energy consumption. Lighting controls can include occupancy sensors, dimmers, and timers. Install submeters to monitor the energy consumption of individual loads. Submeters can help identify areas where energy is being wasted. Conduct an energy audit of the tenant's electrical system to identify opportunities for energy savings. The energy audit should include a review of the electrical system design, equipment inventory, and energy consumption data. Implement the recommendations from the energy audit to improve the energy efficiency of the tenant's electrical system. Consider the use of renewable energy sources, such as solar panels or wind turbines. Renewable energy sources can reduce the tenant's reliance on the utility grid. Conduct a feasibility study to determine the potential for renewable energy generation at the tenant's location. Use power factor correction capacitors to improve the power factor of the electrical system. A low power factor can increase energy losses and reduce the capacity of the electrical system. Install power factor correction capacitors to improve the power factor and reduce energy losses. Consider the use of uninterruptible power supplies helps to provide backup power in the event of a power outage. UPS systems can prevent data loss and equipment damage during power outages. Select a UPS system that is sized to meet the tenant's critical load requirements. Perform regular testing of the UPS system to ensure that it is functioning correctly, and document all testing and maintenance activities. In summary, when designing a tenant improvement within a mall and lacking the available fault current information at the point of connection, follow these steps. Request information from mall management, estimate the available fault current conservatively, discuss with the electrical contractor, and note in design documents. Remember, it is not acceptable to leave fault current verification solely to the contractor, and understand that assuming a large available fault current may lead to overdesign. By following these guidelines, you can ensure a safe, reliable, and code-compliant electrical system for the tenant improvement. For instance, if the mall management provides an available fault current of 30,000 amps at the main service entrance, and the distance from the service entrance to the tenant's panel is 100 feet, using number 3/0 AWG copper conductors, calculate the fault current at the tenant's panel considering the conductor impedance. If the calculation results in an available fault current of 20,000 amps at the tenant's panel, select circuit breakers with an interrupting rating of at least 20,000 amps. Also, ensure that the conductor ampacity is adequate for the load and the voltage drop is within acceptable limits. If the estimated available fault current is used, clearly state in the design documents that the contractor must verify the actual available fault current before energizing the system. Provide detailed instructions on how to perform the verification, including the required equipment and procedures. Require the contractor to submit a written report documenting the available fault current measurement and the basis for selecting overcurrent protection devices. Review the contractor's report and verify that the selected overcurrent protection devices have adequate interrupting ratings. Update the design documents to reflect the verified available fault current and the selected overcurrent protection devices. Ensure that all electrical equipment is properly labeled with the available fault current and the interrupting rating of the overcurrent protection devices. Provide training to the tenant's employees on the safe operation of the electrical system and the importance of maintaining the overcurrent protection devices. Include a preventive maintenance program for the electrical system, including regular inspection and testing of overcurrent protection devices. Keep records of all maintenance activities and repairs. By following these best practices, you can ensure a safe, reliable, and code-compliant electrical system for the tenant improvement, even when the available fault current information is initially unavailable. This approach ensures compliance with the NEC, minimizes the risk of electrical hazards, and provides a safe environment for the tenant and their customers. Remember to consult with a qualified electrical engineer to perform a detailed fault current study and ensure that the electrical system design meets all applicable codes and standards.